All right, so welcome back. We're now going to be talking about polar coordinates. This is something you may have seen before in a pre-calculus class or a trigonometry class. You may have been introduced to this concept before. We're going to go over it as if it's new, though, so kind of explain all the details of it. So in polar coordinates, what we're doing is looking at a different way, an alternative way of measuring the position of something. The alternative way of measuring the position of something. And so rather than, instead of measuring the horizontal and vertical displacement from the origin, like we do in rectangular coordinates, what we do in polar coordinates is we measure the distance our point lies from the origin, and then we measure the angle that's formed with the polar axis, which is our positive x-axis. That's our polar axis there. And that little point there, the origin, is our pole. So if we have some point in the plane here, let's just mark this point right here, call it the point P, then we're talking about P by measuring how far is P away from the center, or away from the origin. So we're measuring that distance, which we would call R. And we would measure the angle that's made with the positive x-axis, right, which should be familiar. That's exactly the same idea that we used for angles in standard position. Okay, angle in standard position. So we measure the angle that we have to go from the origin. And then we would give this coordinates r theta. Okay, so that's the idea of how we label something. Instead of looking at its horizontal and vertical displacement from the origin, we look at the distance from the origin to the point. How far is that? And what direction would we need to set off from? And notice that you can describe any point in the plane by doing that. By telling you by stating how far you need to travel and in which direction you need to travel. If you can describe those things, then you can get to any point. Just like the same idea as the horizontal and vertical displacement worked before. So we can actually describe any point in the plane using this setup of the pole and the polar axes. Now, one thing that's important to note about polar coordinates, though, is that there are multiple representations for a single point. Okay, there are multiple representations for a single point. So, in other words, if let me draw this with my x and y axis. A lot of times I will go away from the xy axis, but for this example, I think it's worth drawing in my x and y axes. Okay. And let's just pick some point in the plane here. And one way, of course, we could describe that point in the plane is by measuring the distance. Right? By measuring the distance from the origin to the point, of course, just like we did before, and by measuring the angle. By measuring the angle. So we'd have a distance r, let's say, and a distance theta. And we would label that point as r theta. Okay? So that's one way that we could describe that point. That's one way that we could describe how to get to that point. But that's not unique. So let me just copy my picture here with my point. And let me show you another way that we could describe that point. So let me just erase by theta and that there. Instead of describing the angle as theta, I could describe the angle like this. Right, so that my point would now have coordinates r, comma, theta plus 2 pi. So because of coterminal angles, we could describe this with any angle that's coterminal to theta. So I could have measured counterclockwise, right, and actually had 2 pi minus theta. That would have worked. Or really theta plus any multiple of 2 pi. Any positive or negative multiple of 2 pi. And that also would let me describe that point. So unlike x and y coordinates, just having the, you can't just say that, oh, that point in the plane, those 2 points are equal, so the 2 parts of the point have to be the same. We actually can't get that now. That's not the case. What we do know is the angles, in this example anyway, have to be coterminal, but things get even more complicated. Because we could also describe our point this way. And we also could describe our point this way. A second here, I just need to adjust the way that this is looking. Sorry, just 1 second here. Okay. So we could also do the problem like this and say, hey, let's measure our angle not to that direction, but the direction in the other quadrant. In other words, I'm going to measure my direction here. Call that theta star. And then I can write this point with coordinates minus r, theta star. Because what that would be saying is I'm facing this direction, but I'm going to go backwards since the radius is negative. I'm going to go backwards r units, and of course that would land me at that point. And so there are a couple different ways that we can describe points. Now, this isn't exhaustive. Of course, we could take anything that's coterminal with that and also, write that with the minus r. Okay. So the only things we know about these points is that given 2 points that represent the same thing, then the radiuses part, the absolute value of those have to be equal. But then we can't even say that the angles have to be coterminal, because this angle here and this angle here are not coterminal, right? They're not coterminal, right? So all we can really say about the angles is it's something like this, right? It can be plus an odd pi, which would get you this direction, and then you'd have to have a negative radius, or it could be plus an even multiple of 2 pi. Right? We really can't say much more than that. Right? So we could say it could be something like this, where if it's odd, then we're this way. If it's even, then we're back to coterminal. So we really can't just equate the parts like we could with an x and y coordinate. So though x and y lead to a unique representation in polar coordinates, that doesn't happen. And what that actually leads to is the possibility that you can actually have graphs that in the physical plane appear to intersect each other, but equation-wise, they won't actually cross because they're hitting those parts in the plane at different times. And that's something we're going to see a little more as we get into graphs. But that is the idea of polar coordinates, and this idea that for a single point there's multiple ways. And all I've done here is just showed you 3 ways. You could, of course, find anything that's coterminal to theta star. So, go around a couple times and then stop there. Okay? And so that is just a quick introduction to polar coordinates. So we're going to take some looks at graphing things in polar coordinates. And, of course, we're also going to want to be able to convert from our polar form back to XY form and vice versa. So we'll be reviewing how that works as well.